So as I said, the next chapter I will be discussing with is your chapter 1, real numbers. Students, you have already gone through these topics of rational number, irrational number, rational number. What is a rational number? Any number of p by q form where the denominator q is not equals to 0 is known as rational number. Okay, so we will be discussing a little bit of again this decimal expansion of rational and irrational number, because I found some of you are still doing some mistakes in your last unit test. Okay, so in the revision, for your revision, let us once more discuss about the decimal expansion of rational number and irrational number. So if rational number is of this type and the irrational numbers are better known as root 2, root 3, pi, etc. Okay. So what about the decimal expansion of rational number? It can be of two types. The first type is terminating. Terminating means, say for example, half, 3 by 4. These are rational numbers with terminating decimal expansion. 1 by 2 is how much? 0.5, 0.3, 0.1. This type of decimal expansions the rational numbers are actually having. Understood? Say, if at all we are not having the terminating decimal expansion, say a number is of like this. What I have written, this type of decimal expansion you are getting, then in which category is it going to fall? It will be again a category of rational number. See, 0.252525. Don't you find a harmony? Don't you find a pattern in the decimal expansion? Yes, we are getting some pattern in the decimal expansion. And what is this pattern is all about? We used to put this bar which shows this particular number 2 and 5 is continuously repeating, which is even better known as recurring. So this type of decimal expansion, if at all you are getting, we call non-terminating, because you can find a dots over here. So it continues to infinity. And we are getting the repeating, recurring pattern after the decimal. So two types of decimal expansion for rational number. But for irrational number, the decimal expansion of the numbers are neither terminating nor recurring. Okay, that means you are suppose getting 2, 5, 1, 5, 4, 3, 2, 7, 9, 2. So do you find a pattern? No, but it is continuously moving like this. I am not getting a pattern here. Understood, children? So keep this particular theory in your mind and answer me a very quick question. What about pi? Yes, whenever pi, this particular word comes into your mind, we are getting one answer, that is 22 by 7, because in class 8 you have used so many times this particular value of pi, no? But this is a purely irrational number. This is also known to you. Now the question comes, if it is an irrational number, how I am writing it 22 by pi, which is taking a rational format, and how I am going to finish this up to 3.14, which is again a decimal expansion of a rational number. So this is a very good question, conceptual question to ask. And students often ask me, why being a rational number, we are putting the value of pi as 22 by 7 or 3.14. So the answer to this one is, children, it is a irrational number. It is an irrational number, that is for sure, and actually this is approximate value. And why this is approximated to 22 by 7? By the way, why not with any other rational number? Okay, so let us concentrate in the decimal expansion of 22 by 7. You are getting like this: 3.142857, 142857, 142857. Do you find something? That is, this particular 22 by 7 is moving on, repeating with the same pattern. Please have a look on it. Please have a look on it. So this pattern is what type? It is non-terminating. It is not finishing. See? But it has a pattern. What pattern? This 142857 is again and again recurring. Understood? Coming back with this particular 6 digit after the decimal. So children, I hope it is very clear. Since this rational number is having this expansion, which is 3.14 approximately, and when you will notice the pattern of pi, it is also 3.14, and this is moving on. Okay, it is moving on and on with no recurrence, with no repetition, and infinitely it is moving on and on. So by looking into only this part common, we are considering, since we need the value of pi to be substituted while finding the area of circle, circumference of circle, this much, and then curved surface area, cylinder, your cone, all these problems you are having, no? Everywhere you need the value of pi. We cannot substitute an infinite expansion. So for that, for our convenience, we are taking the value of pi approximated to 22 by 7 or 3.14. We are asked to substitute this one, but we are taking only this as an approximated. So remember children, pi is an irrational number, but 22 by 7 is purely rational number. Only for our convenience we are putting that one. Okay, so this is important to know for all of you. Now let us go to the another problem where you have, suppose the another important category of problem is where you have to find out the p by q form of any number. Say 1.2525, it is moving on like that. So you need the value of a rational number whose decimal expansion is like this. And what you take, children? You take, let x be that rational number whose decimal expansion is this. Remember, you are doing this type of problem. It is very important category. Understood? So for getting the p by q form, what do? You try to eliminate the recurring part which is coming after the denominator. For that, let us see what I can even do with this one. See, x is this. How to eliminate? What should be multiplied to eliminate the one? Let us multiply 100 on both the sides. See what I have multiplied? 100 on both the sides. So this 25 will come to this side. Say this is number 1, say this is number 2. Subtracting 2 minus 1, what are you getting? 100x minus x is 99x. 125 minus 1. When you are going to subtract it, this one, what you are getting? You will get a cancellation of the factors which are there after your decimal, and you are getting only 125 minus 1, that is 124. So x is 124 by 99. So this is, if it is going to cancel, that is good. If it is not going to cancel, leave it where it is. So this is the rational number they are talking about. They are asking from us to find out the what? To find out the rational number out of the decimal expansion. So it's like a back calculation also. Okay, it's like a back calculation also. Now let us move to like one more example. Say if you have 3, 7, 7, 7, 7, 7, 7. So again you are going to get x as 0.37777777. It is moving on. Now what to do? If you are multiplying 10x, then it is 3.777777 like this. Is it okay? Now if you are going to multiply say 100x, what are you getting? 37.777777. Am I clear about it? Twice I multiplied with this particular x. Once I multiplied 10, so it is coming 3.77777. Moving on. Then again I multiplied this with 100x. So again it is coming, this 7 will be shifting here. It is 777777. Now again you do 2 minus 1. So what you will get? 90x in this side, and 37, this 7777, this recurring factor will be over now. That is our choice. So 37 minus 3, that is 34, and x is 34 by 90. And if you wish, you can cancel it with a 2, that is 17 by 45 is the required rational number. Okay students, so this category is important. Another category of problems in your chapter 1 which is important is the rationalization. Rationalizing the denominator is another very important part. So small questions will be coming. You just follow your NCERT textbook and its example. Now I have taken this problem. Please have a look on it. It might contain 3 marks. This type of problem, what it is? Root 3 minus 1 by root 3 plus 1 as a plus b root 3. Correct. Now children, what to do? First thing, you must rationalize the denominator. Check out this one. By what factor we should multiply the numerator and the denominator? You have to change the sign in the middle. Root 3 minus 1 into root 3 plus 1. And this is a plus b root 3 as it is given. Now, in the denominator it is 3 minus 1. And in the numerator it is root 3 minus 1 whole square. Now opening the whole square, root 3 minus 1 whole square, and the denominator will become 2. I am writing here 2, and this root 3 minus whole square will be root 3 whole square plus 1 square minus 2 root 3. Check this one. So root 3 whole square is how much? 3 plus 1. Can I write it directly? 4. See, this is 3, this is 1, 4 minus 2 root 3. The entire value is divided by which factor? By the factor of 2. Okay. Now this will be separating the numerator. 4 by 2 is 2, or 2 is common from the numerator. So what are you getting? Tell me. I am writing here, okay. See, I am writing here, I am erasing this part. So it will be 2 minus root 3 is equals to a plus b root 3. Now please equate the coefficients of the constant number. A with 2, so you are getting a. And what is multiplied with root 3? Tell me. B, that will be b. So b is here, see, b is here minus 3. A is here 2 and b is here minus root 3. That means the coefficient of root 3 here is minus 1. This is by the method of equating the coefficient of the constant and the irrational part. a rational part and irrational part. So this is the value of A, this is the value of B. Okay, students. So I hope these problems from your chapter 1 and the previous one from chapter 2 are very useful to you, and you got an idea that what type of problems you must practice all around. And, but definitely you must remember all the previous tasks, homework and the NCERT problems are very important. Understood, children? And the extra problems whatever your teachers have provided to you, please go through them. Best wishes for your upcoming examinations. More revisions work we will be giving. Please put it down in your classwork copy, and if at all any doubts, do ask us. Okay, so that's all for today. Have a good day.